ओके, उधर से लेकिन आवाज क्यों आ रही है? क्या वहाँ माइक है उनके पास?
हाँ हाँ सर, आप अपनी तरफ से करिए ना, आप फोन पे हैं इसलिए।
ओके, वीडियो भी क्लियर है सब, मेरी भी ठीक
हाँ फोन कर
है।
दीजिए हाँ।
हेलो,
हाँ हाँ सर, हाँ सर।
shall I start?
हाँ हाँ श्योर सर।
Okay, so we welcome. I think this is the today's last lecture in this today's winter school. Uh,
जी सर।
so the topic assigned to me is on the repeat breeding for the animal side. So as this is a group containing the veterinarians, animal scientists, as well as the agriculture scientists. So I have made this PPT in a way that all can understand. So we will be going a bit slow. Okay, when you say that I should move up fast, I can move a bit faster also. So today's topic is revisiting the repeat breeding in bovine due to early embryonic mortality, innovative strategies for sustained dairy industry, very pertinent to the our 21-day winter school. So as we all know that repeat breeding is a major problem in the dairy sector. So I will be covering this topic in these different headings. So coming to the main topic, the repeat breeding, as the term indicates, means when we are doing the breeding of an animal and it fails to conceive. The purpose of the breeding for the animal is that it get conceived. But upon three or more consecutive AI or natural services, AI artificial insemination, not the this artificial intelligence. It is artificial insemination now. So after three or more AI or natural services for an animal that is very regular, not having any clinical signs symptoms, if that animal fails to get conceived, such type of animal is called as a repeat breeder animal. This is a short definition for the repeat breeding, and this is a major cause for you can say the infertility in particularly in case of the cow. Two major problems if we talk, that is stress and repeat breeding in different states, particularly like if we say major एक कहावत है पंजाब में कि मज्जा मीन्स बफलो, मज्जा बोलती नहीं, मतलब बफलो दे डोंट स्पीक मीन्स इन दे डोंट शो द साइंस ऑफ द ईस्ट्रेस, एंड गामा मीन्स काओ दे ठहरती नहीं, मतलब मज्जा बोलती नहीं तो गावा ठहरती नहीं, मतलब गाय जो हैं दे they do not get conceive easily. So this is the proper saying by the farmers of the Punjab and Haryana there. So if we talk, because these two states are very progressive in the dairy industry, so I am quoting that quote here. And if we if we see the what the loss for that animal, if it is not calving in a year for any dairy farm, I have tell that this calf in a year is a major saying. एक साल में एक बच्चा एक गाय से नहीं ले पाते हैं तो वो डेयरी फार्मर it is in the loss. What the loss is, it has calculated by the around 5 years or the 600 rupees per day, if we say. Or if we talk for the Indian scenario, as we know in 2024 and 25, according to the Animal Husbandry Ministry, the data says that exotic cattle means the HF, pure HF like that, they are producing on an average of 11 kg of milk per day. Crossbred cattle, they are producing 9 kg per day. Indian cattle, they are producing about 4, non-descriptive 3.5, and buffalo, they are producing the 6 to 7 kg. So we can think of what the loss, the major loss due to the less production days for each missed days in the conception of an animal. If we talk 30 to 35 on an approximately rate for the farmers of the milk, and that the cooperative is taking, and if the farmer is selling directly to the end user, it can fetch about the 60 70 depending on the market, depending on the city location. So if animal is repeat breeder, we can think repeat breeder, if missing the one heat, it heats again, next heat will come after the 21 days. So 21 days loss for each missed cycle, or that animal is unable to conceive, we can calculate the how much the economic loss for the farmer is. So this is the major issue of this topic. So what the major reasons for this repeat breeding we can see? If we talk about the fertilization, failure to conceive we are taking, but fertilization, what means the union of that male ova and the female sperm. We have seen all a lot many studies that 80 to 90% is the fertilization rate under the in vitro conditions also. Nowadays we have been knowing about the in vitro fertilization. As we all know the test tube babies or IVF calf production like that. So fertilization rate in another in vitro condition is about 90%. But if we talk about the pan India, the conception rate in terms of the production of the calves, it is only the 30 to 35%, 35 or 40%. Hardly you can say average is 35% across the India as per the data says. So from the 90% of the conception, only 35 calves are getting there. So major 90 minus 35, major loss, you can see it's calculated about a 50%. So where these are going means once the animal has conceived but not able to giving the calf. So about 50% of loss is there in between the conception to the parturition. Parturition is the act of giving the delivery of the calf like that. So we will be discussing this major loss. What are the major reasons of this loss, and what are the possible cause, major steps, innovative steps, how we can mitigate such an issue through the novel approaches. So embryo, we should know what the term is embryo. This loss is mainly due to the early embryonic mortality. So we should know what the embryo is. Embryo is the early developmental stages. So when you can say the from the conception to the when the organs have not yet started. Up to the 40-45 days, the period of gestation period means the period when any this is in the womb in the uterus. So gestation period का शुरू का 40-42 दिन का जो पीरियड है उसको हम ऑर्गेनोजेनेसिस से पहले के पीरियड को हम एम्ब्रियो स्टेज ही बोलते हैं. So this picture will clarify that two major reasons. If you see from the first day of the I am connected here. Hello. Hello.
हाँ सर.
Yes, sir.
Okay,
may
okay.
continue, sir.
In between पता चलेगा तो we will continuing ना. Okay, thank you.
Sir. You can continue, sir.
So I am going in the right way also. The
sir.
Yes, sir.
speed also. Okay, thank you. So from day one, if we talk day one, the conception, the stage is called zygote. We own that, and the developed stage up to the 7 days, the blastocyst. Now you can see from day 1 to day 7, when if the loss of the pregnancy is there, it is called a very early embryonic mortality. And from 7 day to day 16 or 17, it is I will discuss later on why I have emphasized here 16 and 17 day. So loss of the embryo from the 7 to 17 day, it is called early embryonic mortality. Together they comprising, if we see below here, 28%, 30%, about 55% loss in the gestation. It occurs during this stage only before the 17 days. And when there is any loss of the embryo is there about 16 days. At that time, the cycle length, that we have discussed 21 day, will not be elongated. Means अगर 17 दिन के बाद कोई भी abortion और you can say the miscarriage होगा तो उसके बाद क्या होगा, उसकी साइकिल लेंथ बढ़ जाएगी. 21 दिन की बजाय जो स्ट्रेस इंटरवल है वो 25 दिन, 26 दिन, 27 दिन लाइक दैट हो जाएगा. सो रिपीट ब्रीडिंग हमने जो बोला था, साइकिल लेंथ विल रिमेन द सेम. नाउ वी हैव कम टू द कंक्लूजन दैट मेजर लॉस दैट अकर्स during the gestation, it occurs during the before this 15 or 16 days of the pregnancy. So we will be focusing much on these days. Other losses, we all know that what are the perinatal mortality, what is the abortion, what is the you can say the neonatal mortality. So this we will not be discussing in detail. So if we see the embryo development stage, so let us first discuss how this pregnancy get maintained. In I think one was okay. I will skip that slide. We will come again back to that slide also. If we see the normal estrus cycle, as I am talking about the 21 days, you can see here 0 to 21 days is the cycle length. In this different phases, first you can see here LH hormone. We can see here it is causing the ovulation. Means जो follicle जो बनना है इसके अंदर जो oocyte जो है follicle will get ovulate and it will release the ova. It will be captured by the oviduct and the fertilization will occur. Say if animal is cyclic, we have not made it AI. We have not allowed that animal for the natural breeding of the AI. So how the cycle will again come? You can see here. After the ovulation, the hormone that is responsible for the ovulation is LH. Okay. And before that, you can see the estrogen, E2. We have depicted this as the E2 and the estrogen. So before the ovulation, this is the peak that shows the signs of the estrus, like the mounting, wallowing, frequent discharge, all those frequent urination, discharge, hanging, all those signs are due to the estrogen, and which will lead to the peak of the LH causing the ovulation. After the ovulation, one structure gets formed. That is, we all know that is the carpus luteum, which is the body temporary endocrine gland secretion secreting the progesterone hormone P4, progesterone hormone that is responsible for the maintenance of the pregnancy. So now, if you see, if the pregnancy does not occur, we have not made that animal AI or like that, this progesterone level will get fall after 16-17 days. You can see here 15 days. Now 16-17 days after, it will get fall, and estrogen level is increasing. Or other way we can also say, due to the non-establishment of the pregnancy, there is no signaling that pregnancy will be getting sustained. Estrogen receptors on the uterus will increase, causing the decline in the progesterone. Together, they will again allow the animal to come in the cycle. So, coming to the previous slide. So, for the embryonic development stages, we can see here, if the timeline is there, after the AI, first cleavage, 30 hours, then cleavage 2, then morula of the blastocyst stage, we have discussed up to the 7 days. Then zona, that is having the initial mass, and that will get hatched. Now comes the, you can say the trophectoderm, and then the 15-day here. You can see here, it is a blastocyst transition phase. What is the transition? Very huge expansion of the blastocyst is taking place. From the 14 day, you can see it is 6 mm only, and from in 16 on 16 day, 2 days after, it is about 60 mm. So you can say it is a before these days, these 14 and 15 day, it is a huge transition phase of the blastocyst. And in the right side of the figure, you can see here this blastocyst transition phase. It is giving the signal that is called as the interferon tau signal. So earlier, what we have discussed, if this estrogen receptors is there, it is causing the oxytocin receptors on the uterus, causing the secretion of prostaglandin. It will cause a lysis of the Cl, and animal will come in the estrus again. But this interferon tau, you can say that when the fetus is there, it is giving the signal. Some other another way, that signal is interferon tau, causing the down regulation of the estrogen receptor and oxytocin receptor, and the animal will not come in the cycle. So this, you can say, this synchrony should be made for the sustenance of the pregnancy. Now, what are the major risk factors for the early embryonic mortality? Species, breed, priority. If you can say the breed that are giving the more milk, that are prone for the high embryonic mortality. Priority, if the animal is having the 4th, 5th priority onwards. Priority means how many calves it has given. So animal is getting senile. Together, these reasons may be the causing for the unhealthy uterus and causing the early embryonic mortality. Fetal plurality means having more than the one fetus, particularly in case of the bovine species that used to give the one calf only. That is also the reason for the early embryonic mortality. Milk yield, it is more the milk yield. As we in the reproduction side, there is a term that reproduction and production, they cannot go to the maximum at the same time. So now the maximum term of milk yield has been converted to the optimization of the milk yield, and the reproduction should be considered. So if the animal is of the very high milk yield, it is causing some of the negative energy balance in the uterus, that is causing the early embryonic mortality. And breeding method, in breeding, we all know that in breeding may be reasons for the early embryonic mortality. Seasonality, summer season, more embryonic mortality is there. And BCS, animal is poor BCS or over fatty, together they may be the reasons for they are the reasons for the early embryonic mortality. But exactly the causes of this early embryonic mortality. One, the major important cause is the genetics, chromosomal level or the cytological or the genomic level. These singly accounts for the 20% of the embryonic mortality. Although these has been, you can say, very less undertaken, but studies says that around 20% of the embryonic mortality is due to the chromosomal defects. Some of the major chromosomal defect that we all know, that is a Robertsonian translocation. We have studied at the level of our intermediate. It is the exchange of the chromosome between 1 and the 29 chromosome, leading to the early embryonic mortality. Major drawbacks, major defect during the early development, or you can say during the meiosis stages or during the developmental stages taking place, that is Robertson translocation, leading to the poor development of the embryo. Another reasons are polyploidy, like triploidy, means polyspermy, when more than the one sperm get fused due to the aging of the ova, vital and membrane get weak. More than the one sperm get entered in the vital membrane, leading to fusion, leading to the polyspermy, polygyny, where the this polar body cannot get escape and get fused by the sperms. So you can say the polygyny may lead. So these will lead into the abnormalities and the eliminated dumps. Nowadays, Government of India has laid down the MSP, minimum standard protocols, for the establishment of the any bull or semen center. These are genetically tested, that there should be no dumps and clad certain diseases. Dumps deficiency of uridine monophosphate synthesis. It is a very important enzyme, that absent of such type of enzymes leading to the many disorders, and such type of disorder, if a bull is the recessive of such type of the genes, it is causing the lethal effects. Infertility due to the early unnoticed infertility due to the embryonic mortality leads there. Now, complex vertebral defects and expression of the gene in cumulus ufus complex. Oocyte is being surrounded by the cells that is called as a cumulus ufus complex. There are lot many genes. The upregulation or the downregulation are affecting the development, or even the ovulation and the subsequent development of the oocyte, as well as of the developing embryo. So gene level studies has been done, and we will discuss later a few genes. Endocrine dysfunction. Coming to the one of the major important reason for the early embryonic mortality is the disturbance at the endocrine hormonal level. We have discussed few hormones like LH, luteinizing hormone, estrogen. Anti-Mullerian hormone is a very novel, can say, that has been uh, thoroughly studied in human side only, but now it has been recently undertaken in the veterinary side also, or in the dairy sector also, the role of the anti-Mullerian hormone in the fertility or the infertility. Certain neuropeptides, luteal phase defects, we will discuss one by one and a bit faster. Luteinizing hormone, we have discussed by the name also, that the peak of this hormone is causing the ovulation. So whenever there is subdue level of this hormone, or insufficiency of the LH hormone is there, or we can say mismatch or incorrect timing of the LH surge is there. LH surge means a sudden rise of the in a very low, in a very narrow time window. The rise is called as a surge. So LH surge will lead to the ovulation, but incorrect timing of the LH surge leads to the failure of the ovulation or ovulation of the aged ova. All these will lead to the early embryonic mortality. जो ओवा रिलीज होगा वो ऐसा होगा, एजिंग हो जाएगी, या प्रीमेच्योर्ड ओवा रिलीज हो जाएगा, या फिर रिलीज ही नहीं होगा. So all these will be responsible for the you can say either the fertilization failure, or if the fertilization will occur, it will lead to the failure of the subsequent embryonic development. So again, another hormone is estrogen. We have discussed that estrogen is responsible for the high level of the LH. But if estrogen level is high during the post-ovulatory phase, means after the ovulation, another follicle is growing on the ovary also, that is also causing the estrogenic level, that will cause the asynchrony. Asynchrony means in the uterus, means एम्ब्रियो की स्टेज क्या है और यूट्रस की क्या स्टेज है. ईस्ट्रोजन लेवल अगर ज्यादा रहेगा तो इन्फेंटिबुलम से ऊपर जब नीचे निकलेगा, जब ओविडक्ट में जाएगा, इट कोज इरिथमिक, मतलब जो ओविडक्टल कॉन्ट्रैक्शंस होंगे वो प्रॉपर नहीं होंगे, और एम्ब्रियो जो है अर्लियर और लेटर यूट्रस में आएगा, तब तक कि यूट्रस तैयार ही नहीं है उसको नडिशन के लिए, इम्प्लांटेशन के लिए. दैट इज कॉजिंग द इम्प्लांटेशन फेलियर एंड द अर्ली एम्ब्रियोनिक मोर्टेलिटी. Now, anti-Mullerian hormone, very novel studies we have conducted in the Ludhiana and the other centers also, that presents this anti-Mullerian hormone is a very important hormone in screening of the animal also. Good level of the anti-Mullerian hormone, but this hormone is gaining popularity because this hormone does not vary with the different physiological stages of an animal. So this can be used as a biomarker in case of the screening or the fertility of the animal. Optimum level of this hormone means animal will be having the good fertility, will not be having the early embryonic mortality like problems. So this hormone has been used by various you can say researchers to screen the animals, as well as the novel technology that we are saying, that embryo transfer or in vitro fertilization, collecting the oocytes directly from the ovaries, So this hormone is again a biomarker. More is the value of the AMH, more is the pool of the follicle is there, growing pool. So that animal will be having a more number of the oocyte to get recovered and better chances of the embryonic development under the in vitro conditions. Opioids, whenever there is a stress level, opioids get increased and the GnH pulse center will reduce. GnH is the hormone that is causing the release of the FSH and LH. If disturbance is there, it is causing the early embryonic mortality. Luteal phase dysfunction. After the ovulation, there forms a luteal tissue. But if that luteal tissue is insufficient in terms of the size, insufficient in terms of the number of the cells that are responsible for secretion of the progesterone. So such type of insufficiency, that poor steroidogenesis, the progesterone synthesis on the CL, on the luteal tissue form, either in the size, physiological, or as well as the structural abnormalities or dysfunctioning, will lead to the improper amount of the progesterone that will be leading to the early embryonic mortality. Immunological causes, we have discussed that optimum level of the interferon tau is required. Interferon tau, as we all know that it has also been secreted by cells against some of the you can say the virus. So this hormone, this signal should be optimum as during the implantation stage. What the embryo is? Embryo is the allograft type, means the foreign tissue for the uterus. So immunity suppression is required. So interferon tau do that both the functions, signaling that something is there in the uterus that need to be implanted, reduce the immunity of the animal, but on the same time the optimum level of progesterone that we have discussed in previous slide also is required, so that compatibility in both these two is required for the implantation. If any disability, dysfunctioning is there, it will again lead to the failure of the implantation. Subclinical endometritis. We have discussed that what the repeat bleeding is. It is not having any type of the clinical signs. Owner is asking that this animal, this guy has been inseminated 3 times, 4 times, 5 times, or even from a year also, but it not all the discharge or the physical signs of the stress are normal, but owner is unable to find, doctor the field level is also again unable to find what the major root cause is. Major root cause nowadays, it has emerged that is a subclinical endometritis, means clinically it cannot be detected, but internally the uterus is having the mild level of the infection that cannot be detected by the ultrasound, even by the ultrasonography, even by the hands, or even by the discharge. So what it needs, we have to take the sample from such repeat breeding animal, and we will make the cytological slide, and we can see if the number of the cells, neutrophils particularly, if there are more than the 5%, then such animal is said to be the endometritis, subclinical endometritis. And endometritis होगी means uterus में mild inflammation होगी, तो inflammation होगी तो जो early embryo जो develop हो रहा था उसको implantation के लिए वो एरिया ही नहीं मिला जहाँ पे वो implantation होगा. That is that cytotoxic effect of the embryo, or you can say MUC level, जो एक म्यूकोपोलीपेप्टाइड्स हैं उनका लेवल प्रोटीन का हाई रहेगा वहां पे, जिसकी वजह से वो इम्प्लांटेशन नहीं हो पाएगा. These are the certain reasons for the subclinical endometritis. I have classified in terms of the bacterial, viral, and protozoal. Among them, BVD, bovine diarrhea, and bovine herpes virus. These are the two commonly diseases that even we have discussed the MSP, minimum standard protocol for any establishment of any bull center or the production of the semen. These bulls should be negative for particularly first two diseases, BVD and bovine herpes viruses. And we have also seen that these are causing the intensity of causing the early embryonic mortality is very high in such if the bull is having the such infection or semen is having the such infection. Nutritional causes and negative energy balance. Overnutrition and undernutrition. Nutrition is again a very big topic. We all know that optimal level of nutrition is required. High level of nutrition due to the high milk production is again causing many abnormalities, many metabolic changes in the uterus as well as in the blood that are making the environment unhealthy, lethal for the embryo. as well as other nutrition. We all know that India, under the Indian condition, in many states, proper optimal nutrition is lacking. So we all know that reproduction is not an essential process; it is a luxurious process. The nutrition requirement, if the body is having the requirement of the nutrition for another purposes, then only the remaining energy will get diverted to the you can say the uterus side for the reproduction purposes. So this is the you can say the hormonal level changes. Low level of the IGH will causing the GnRH level low. GnRH is the gonadotropin releasing hormone. It is the main hormone that is having the role in development of the follicle, releasing the FSH and LH. Both these hormones we have discussed. If it is less, LH FSH is less, and then abnormality in the ovulation will be there. Embryonic growth and interferential production will be less. Another, you can see the management. Now, what happens that we should know the optimum time of the AI. Very, very emerging problem you can say is there, that detection of the estrus and as well as the correct timing of the AI. So what the true science, as we know that nowadays, what happened, the herd size has been reduced, as we discussed in the last line also. Herd size is reducing. And when less number of animals are living together, or nowadays only the single animal as it's present at the farmer doorstep. So alone single animal, the expression of the estrus signs are very poor. So how the owner can detect the estrus? And when detection of the estrus is improper, we cannot achieve the correct timing of the AI. And if the AI is done at a very early stage, at very early stage means early stress stage. So what will happen? Semen will get die earlier and ovulation will not take place. If AI is done at a later phase, after the late stress, after the, you can say towards the end of the estrus, even just before the end of the estrus. So what will happen? Ova already released, and aging of the ova, or you can say the derangement changing in the ova will occur and it will die. Even fertilization can occur, but early embryonic mortality will occur. So this is a major problem emerging nowadays. The managemental error is there in the AI. Environment, we all know that is the very hot topic, that global warming is concerned, and if the THI environment temperature is above the THI thermal humidity index, then animal will be having the stress, and the stress condition and other GNRH level be less, and all those oxidative reactions will be there. It will impair the oocyte as well as the sperm quality, leading to the fertilization failures, and all those you can say the changes in the uterus. So that will lead into the infertility. You can see the effects, direct as well as the effect of the heat stress. Direct stress is we have discussed many times that ultimate hormone, that is a GnRH, is the hormone that starts as well as you can say starts the folliculogenesis as will lead to the ovulation, the GnRH. Heat stress is reducing such type of the hormone, as well as you can say when this hormone is poor again, and the environment of the uterus, compromised environment of the uterus is there, एंड फॉलिकल डेवलपमेंट, जो फॉलिकल बना वो भी अच्छा नहीं है, और साथ साथ यूट्रस का एनवायरनमेंट भी अच्छा नहीं है. तो इट इज, यू कैन से, दोनों ही चीजें खराब. यूट्रस भी हेल्दी नहीं है ड्यू टू द हीट स्ट्रेस, एज वेल द फॉलिकल जो डेवलप हुआ वो भी हेल्दी नहीं है. सो इट विल बी लीडिंग टू द यू कैन से द लॉस ऑफ द एम्ब्रियो or the failure of the fertilization, and leading to the repeat breeding condition in the animal, particularly in case of the cow, as well as the buffalo also. Miscellaneous causes, certain toxins that has been used. You can say the agriculture chemical exposures has been used nowadays. That has been, it has been found in a study in University of Ludhiana also, that level of such type of the you can say the chemicals is found many times, even 100 times. Certain chemicals are found, their concentration is 100 times higher at the gonadal levels, means the ovarian uterine level, compared to the blood. So if we take the sample in the blood, and very in the nanograms, very less level is there of some of the chemicals, pesticides, but towards the, you can say the uterus and ovarian end, this level is 100 or even 500 times more of certain chemicals. So it means that uterus, or that has the, you can say, sensitivity for certain chemicals, and the chemical get you can say stored in the uterine ovarian junction, leading to the certain changes that we can also see some of the burgers and preservatives that nowadays people has been eating. So these also lead to the infertility problems in both male and as well as the females. So coming to the diagnosis, how much time is left? Hello, hello, hello.
हाँ सर, हाँ सर.
So how much time is left now?
Sir, you can complete topic, sir.
Okay, okay. So towards the diagnosis, there are lot many studies. We can do the diagnosis from the slaughter. What is the exact time of the embryonic mortality? Post AI, if we collect the samples, flush the uterus, we can also see the development stages of the early embryos, early pregnancy. Some factors that are responsible for maintenance of the pregnancy, their level like EPC, EPF, as well as the pregnancy associated PEGs that has been increased nowadays. PEGs, certain progesterone daily assay. We have seen that nowadays kits has been working. That those mostly the kits that works for the early pregnancy diagnosis is the PEG based pregnancy specific glycoproteins. Then in vivo imaging by the ultrasonography you can test and uterine health. These tests can be helpful in the diagnosis of the reasons, what the exactly the reason for the early embryonic mortality. Plant slaughter AI means, although this type of the study is not possible in India, we do the AI for a group of an animal and we slaughter a particular group, and later after 2 days, 3 days, 4 days later on, we said we slaughter a group of animal. We can find out the developmental stages and we can see what exact on which day exactly the major loss of the embryo is happening there. So that is slaughter study. Same can be repeated under the live animal, but by the flushing of the uterus means some of the, you can say, chemical, particularly the Dolbecos phosphate buffer saline is being inserted in the uterus, and by the West catheter it is collected back. With that fluid, the fetus will also come, or the certain cells or the early embryonic development stages will also come. Now, if depending on the day of flushing, we can think that we have induced the embryonic mortality, and if the cycle length is not changing, so that is the typical phase where the embryonic mortality is happening without affecting the estrous cycle length. Say for example, if we do the flushing at 14 days, uh, intentionally we have wiped out, flush out the developing embryo, and cycle length is not changing. And if we do after 16 or 17 days, that cycle length is increased to the towards the 25. It means that MRP, maternal crucial pregnancy, has happened there, and in natural condition, if repeat breeding is there, so cycle length is same. So that loss of the embryo has been happening before the 15 days. So another study is that by assay, having the assay of the progesterone. Progesterone is that hormone. We have seen that it is being secreted by the CL, corpus luteum. So CL that formed after the ovulation, and it increases in the size 5, 6, 7 days later on. And if we do the testing, and we have seen that from 17, 18 day onwards, there was lysis of the progesterone also. So post AI, if we do the sample in the blood as well as from the milk also, so progesterone assay can be helpful based on the values that animal is pregnant or not pregnant. These are the values around 2 nanogram. We can say if it is about the 2 nanogram on day 18, 19, 20 post AI, animal can be supposed that it is pregnant. Early pregnancy factors. These are the factors that has been secreted by the embryos, and certain factors we have seen that these detection of these factors is also very costly. So it is not very routine procedure. Studies have shown that different factors are being secreted apart from the interferon toe, are being secreted by the developing embryo. If we detect by the ELISA or the RIA, radioimmunoassay, that can be used in future as a tool for the early embryonic this detection of the pregnancy at the early stages. Now, but we are told that PEGs, these are being secreted. Pregnancy-associated glycoproteins are secreted by mononuclear cells as well as the binuclear cells from the trophectoderm and can be detected in the maternal serum. So, if we do 24-day post AI, the level is increasing of these pregnancies of glycoproteins, and their level If animal is repeater, means animal is not repeater, maybe that animal is repeater, but owner has not yet detected that animal was in the heat after 21 days. So he want to go rely, a big herd is there, he want to rely only on the testing. So आप एनिमल का, सभी एनिमल का ये है कि बाद 24 दिन के बाद ब्लड ले लीजिए. If animal is having high level of pegs, it or the good the critical value of the pegs, it means animal is pregnant. Else if cycle get repeats, it means that it is in the phase of the estrogenic type of the phase, so pegs level will less. So this is the good, you can say the hormone, or you can say pregnancy proteins that are being used in the rapid kits also. In vivo imaging. Now, imaging ultrasonography is a good source, good tool, emerging tool for nowadays in the field condition also to detect the early pregnancy, because it requires only one time setup. It does not require repeated use of the kits, repeated taking of the samples, and all those things. But as initial input is expensive in terms of purchase of the machine, as well as expertise is required to detect the pregnancy. We can detect the pregnancy by ultrasonography as early as 22 days also. Heartbeat get developed on 22 days. So we can see the heartbeat, or else on 22 days we can see, or before that also we can see the CL. If the blood flow is very good, as above two pictures are showing, it means that animal is pregnant. Animal is pregnant. Okay. CL, as well as on the same side, we can see the uterus. If possible, the some black spots indicating the fluid, or fetal heartbeat can also be seen. Together, both the findings will indicate that CL after 21 days, if the CL is there and the uterus having the some fluid or heartbeat is there, animal is pregnant. But that needs a very expertise. Evaluation of the uterine health, as we have discussed, that examining the uterine health, if animal is repeat breeder, we due to the reasons that cannot be detected in the clinical cases. So subclinical dermatitis was the one of the major reasons. So in certain cases, we can go with the taking of the swab sample without affecting the uterine endometrium. So novel technology is the cytology. Cytological brush is being inserted. That's the same brush that is used in the human also for the pepniclov smear staining. Some particularly in case of women who take the samples. So by that sample, we just, you can say, swab or clockwise or anti-clockwise in the one direction, and that swab is being collected in the sterile way, and smear is made on the clean glass side. If the PML cells are about to be more than 5%, you can say animal is having affected with the subclinical endometritis. Beauty of this test is also that if we have done that examination immediately, you can say within 15, 20 or 30 minutes after the examining the animal, the value of PMN cells comes out. So we can also do with the AI, क्योंकि यूट्रस में हमने ज्यादा मैनिपुलेशन नहीं किया है. अगर हम बहुत ज्यादा इसको पहले करते थे यूट्राइन से बायोप्सी, means tissue sample is being taken. So in that case, you cannot do the AI, because when the uterine endometrium is damaged, so chances of conception is get reduced, because damaged endometrium will release the prostaglandin. It will cause the lysis of the carpus luteum. That's why we say that during the AI, if blood comes for the beginners like that, that blood will supposed to harm the developing embryo as well as the release of the prostaglandin. So with this technology, cytobus technology, very latest technology, we can do the AI in the same examination time. Certain therapeutic aspects, hormonal strategies, no, depending on the causative agents, depending on the diagnostic tool, we can also go with the you can say different treatment therapeutic approaches, like the hormonal, non-hormonal, strategic, nutritional, as the factors were there causing the repeat bleeding. We will discuss one by one. Major reasons, major therapeutic approach, we can go with the human coherent gonadotropic, HCG. Many times you have seen that in the field, persons, what they do with the AI, they say that एक ठंडा टीका लगाते हैं, कंसेप्शन चांस बढ़ जाएंगे. दैट इज माल प्रैक्टिस, प्रैक्टिस इज बीइंग टेकन इन द फील्ड. what science says that giving the injection after 5 to 7 days post AI, it will increase the chances of another follicle that is developing to get luteinized, either the luteinized or to ovulate. That will cause the luteinized tissue, increase in the volume of the luteinized tissue. Subsequently, progesterone level will increase, and that what we have discussed, luteal deficiency will not occur, and chances, you can say the therapy is there. So, with this therapy, the chances will get increased for the pregnancy sustained conception rate. So we have done this experiment in the you can say that during the embryo transfer technology also. We nowadays recommend that during the ET embryo transfer that is being done on the 7th day of the AI, normal AI is done during the estrus, and on 7th day of the estrus we do the embryo transfer, and simultaneously if we give the HCG, that will increase the chances of the progesterone secretions. In place of the HCG, we can also give the GnRH similarly on same days. It will increase it. What GnRH is? It is causing the endogenous release of FSH and LH. HCG is directly the LH, and GnRH is inducing endogenous FSH and LH doing the same function. Now, progesterone, what happens? We have discussed deficiency of progesterone will lead to the low level of interferon, and it will lead to the poor signaling, and it will lead to the repeat bleeding, early embryonic mortality. So, giving the progesterone injection, but we have to give it, you can say, in terms of implant. Means if we implant some progesterone device for 5 to 7 days, the chances may get increase of the progesterone secretion, leading to the more conception rate. But as soon as we remove the implant, there are chances that, as we have seen one graph in earlier phase, decline in the progesterone level will cause the LS surge, and that may cause dysregulation in the estrus cycle. So this is not very, you can say, field subjected. Recommended for the field. Kisspeptin is a novel compound that is required, but you can say morning, evening injections are required for this kisspeptin, and it's having a very less biological value. It is also increasing the acidic corpus luteum function, but it is very costly. Interferon tau, that we have seen that interferon tau is a chemical mediator causing the signaling for sustain of the pregnancy. So direct people have given interferon tau. Again, it is very costly. It will cause the reduction in the estrogenic receptors, reduce the prostaglandin synthesis, maintain the pregnancy. COX-2 inhibitor. It is nowadays people have been doing the research. COX-2 inhibitors are the inhibitors, you can say, that will inhibit the pathway of inflammatory changes. Prostaglandin release is an inflammatory molecule. Prostaglandin को रिलीज होने से उसके इफेक्ट्स को रोकने के लिए COX-2 inhibitor दिया जाता है, particularly like meloxicam, flunixin, merbamine. People have been giving that, and some you can say both type of results. Some found fruitful, some found no significant changes. So this wide scope is there to optimize the dose as well as the timing of giving the COX-2 inhibitors. And treatment for the infection cases, we can go with antibiotics. Antibiotics can be given systematically. Antibiotics can be given intrauterine, if depending on the subclinical endometritis, how much level of the infection is there. Hormonal therapy or combined therapy can be done. Means hormone therapy means a prostaglandin we are given. Prostaglandin is a hormone that will cause the evacuation of the uterus. Any infection is there, it will cause the evacuation of the uterus. Simultaneously, we have given the antibiotics, systemic as well as the intrauterine. They will cause the any infection to come out, and in the subsequent estrus, the AI could be done to increase the conception rate. Some immunomodulators has been tried, having the different you can say the roles, different mechanism to increase the chance of the conception. Among them, LPS and glycogen has been used to increase the chance of the conception rates. Nutrition measures, we all know that optimum level of nutrition is required, so that the negative, as we discussed, the negative as well as the positive, high level of the nutrition, particularly the protein diet, cause the increase in the ammonia in the blood. Both protein, both high level, particularly the protein, and the low level of the energy, they are causing the early embryonic mortality. So optimum level of the nutrition, particularly for the milk, those animals that are in milking, that is required. Iodine, beta carotene, they're supposed to have the supporting role in the CH synthesis. So optimum level of nutrition, we all know that is required. Environmental factors to mitigate the heat stress. We know all the strategies like giving the shade, providing the cold space, particularly in case of winters, particularly in case of summer. Sorry, good ventilation, fan, water immersion ponds, particularly for the buffaloes, like wallowing. We have seen that wallowing buffalo are very fond of the wallowing. So people or good institutes they develop the wallowing tanks also. Um so these to mitigate the heat stress, and cold is also a reason for some of the stress in when extreme cold is there. Treating with anti-sperm antibodies, although not very fruitful study in case of the animals, but anti-humans, we can give the concept here. We can change the bull, or we can change the semen, because in the container we can carry the lot many semen of the different bulls. So in the human side, the possibility can be met out by using some anti-sperm antibodies. So increase the chance of the conception. Coming to the conclusion, early embryonic mortality is a critical barrier for the reproductive success in bovine, reducing the fertility, extending in the intercalving interval, leading to the major economical losses, particularly for the high producing dairy cattle. Because early embryonic mortality here is not a single etiological factor, it is a multifactorial cause diagnosis. Its diagnosis is not cannot be relied on any single test. So we each case should be treated as individualized approach should be followed, and a most effective approach depending on the case, depending on the causative regions, should be practiced to improve the conception rate. Many times we focus only towards the fertilization, means timing of the AI, and you can say the double dose AI and semen handling, but this will increase the chance of the fertilization only. But we have seen that uterine health is important, and we have also seen that fertilization is 80 to 90%, but end product, the calf production, is 35%. So we should must focus on the health of the uterus to optimize the calving rate. So what the future directions we can meet out from this presentation is that we should develop some of the kits markers for detection of the early pregnancies. And nowadays we see that AI, from AI to AI, what we call that, from normal artificial insemination to artificial intelligence tool has now been emerging for the easter detection, their physiological states, CCTV camera monitoring of different signs of the estrus, even the rumination, even different metabolic activities, so, by which we can detect that animal is going to affect with certain disease, going to fall ill in 1 or 2 days, or in the evening. So such type of level, such level of, you can say, AI tools has been developed in the dairy sector. So that can be used in future also. That's all. Thank you for the giving the time. Thank you for the chairman, co-chairman, and the complete organizing team to giving me chance.